Hey everyone, this is the Argonne Fermi group, and this is our final presentation. Joining me are Andrew and Helen. To give a quick project overview and a high-level background, the U.S. Department of Energy published laboratory incident reports, also known as the lesson learned documents, from national labs all over the country, and these documents are very beneficial for Argonne and Fermilab projects because this helps the projects learn from past safety incidents. The problem is that there's a huge volume of these incident reports, and the database for these incident reports is ever updating. And since Argonne projects have very long durations, they need to continuously search for new lesson learned documents and have the newest and most relevant ones pushed to them. Argonne has automated this process with a machine learning pipeline to identify lesson learned documents with relevant information for their ongoing projects. So for our goal in the spring quarter, we aim to improve the efficiency of this pipeline in addition to adapting the algorithm for Fermilab data. So ultimately, we want to deliver an improved version of the work control document and lesson learned document matching methodology. A work control document, by the way, is a project description for the labs that go on at Argonne and Fermi. And we want to deliver this methodology that yields high-quality matches for both Argonne and Fermi documents. To give you some examples of the documents that we mentioned, first is the lesson learned document published by the Department of Energy. As you see on the right, this is an example. They are structured well and contains a lot of information, and they will be summarized in our methodology. Secondly, we have the Argonne work control documents. On the right, here's an example of the task description part of the document, which describes the projects that go on in Argonne. And these will be pre-processed and tokenized, etc., to be able to match with the lesson learned documents in our methodology. And thirdly, we have the Fermi work control documents. On the right, here's a few examples of the data part of the document, which is the most relevant ones. As you see, this is less structured and needs more pre-processing compared to the Argonne data and structured completely differently, which is why we need to fine-tune our methodology to adapt the algorithm to be able to work on these data as well. Originally, we received very limited data, 5 lesson learned documents, 6 work control documents at Argonne, and 5 high-quality Fermi work control documents. Halfway through our project, we received a bigger data set for additional testing at 24 lesson learned documents and 532 Argonne work control documents, which was extremely helpful. And now we will walk through our results and what we achieved, starting with Helen giving us a high-level overview of the benefits achieved.
In order to contextualize our results, first I'm going to give a brief overview of what the past team has built. So they built this pipeline between the Department of Energy lessons learned and Argonne work control documents using the human summary part of the lessons learned. They built this similarity analysis algorithm with this 6 algorithm displayed here to do the similarity analysis. However, the previous team found that the human summary part of lessons learned are of low quality as well as high variant. So they deployed large language models such as Llama 2 to generate supplementary summary to help improve the summary quality. So the first benefit that our team has achieved is that we found a better preprocessor and achieved better preprocessing of the text documents in terms of efficiency and accuracy. And secondly, we found alternative better models for summary generations, as well as try fine-tuning the prompt to improve the summary quality. And lastly, since this existing pipeline was built for Argonne work control documents, but Fermi data has very different structures, we actively rework these solutions to deploy on Fermi data. And now I'm going to pass on to Kevin to talk about the improved results in preprocessing.
In terms of pre-processing, we switched the package completely and found a new one that works significantly better. Previously, we used the NLTK package, and now we switched to SpaCy, which resulted in a 37% improvement in efficiency, meaning 75 seconds saved per document. And this is a huge time saved when we're processing thousands and thousands of documents in one go. And also, with additional capabilities of this new package, the results become more generalizable, more suitable for laboratory document setting. For example, lemmatization allows the preprocessor to reduce all the word forms to their original forms, which is more standardized going forward. Additionally, the word type identification capability of the SpaCy package allows us to separate nouns, adjectives, and verbs. And for lab documents that don't have as many adjectives, for example, we can get rid of adjective identification to save efficiency, improve efficiency. To give you an example of the different output generated by NLTK and SpaCy, here's the same word control document going through the two preprocessors. As you see highlighted by the green part, the most important words, the keywords, are all retained by both documents, by both preprocessors, which explains why we ultimately achieve the same recommendations at the end. However, as you see, the difference are some of the more nuanced words in the adjectives. For example, under, occupational, independent, quantity, train, etc. are retained by NLTK, whereas address and case are retained by SpaCy. However, this does not affect the overall matching methodology at the end, but with improved efficiency. Next, I will pass on to Helen to walk through the improved lesson learned summaries.
So the first improvement we found is a better model. The previous team used Llama 2 to generate summary and has a result of summary repeating the prompt and generated content, as shown by the left graph here. Upon trials and errors, we found that Llama 2 instruct has better summary generation with less repetition and thus more meaningful summaries. An example is here on the right graph. We have concretely safety lessons learned identified as well as future considerations. We also identified several other LLM potential options for future teams to explore, such as Llama 3, Llama 3 Instruct, and Pegasus. And then we fine-tune the prompt based on the previous team's general template, as shown by the graph here. So the general template instructs the large language models to basically generate concise summary, summarize main findings, identify key lessons learned, provide recommendations, ensure clarity and coherence, which are all very general instructions. So we tested prompts that highlight safety issues based on this. So we added do not summarize project ID, time, and background, and we modified general terms like key lessons learned, main findings to safety-related process or lessons learned. We found out that the overall match accuracy decreases slightly from 33% to 27%. However, we believe that there are ample room for improvement in fine-tuning the prompt and finding the optimal solution for generating a meaningful summary. And during this working process, we also improved the script flexibility from previous team's workflow. So previously, the model name and template were all hard-coded into functions, and now we have model name and template taken as variables, as well as develop a new script for efficiently testing different prompts and models. Now I'm going to pass on to Andrew to talk about the results on Fermi data.
So the process that we described was running our methodology on the Argonne data. A new challenge was to run this on the Fermi data, which presented some new challenges. The foremost was that it was lower quality data with briefer text. There were several things that we did to address this. The first was a refactor of the code. As Helen mentioned, the code was there was some hard coding and it was tailored to work on the Argonne data. And so we had to update it to work with the new format of the Fermi data. We also had to work with this briefer code and the low quality matches that resulted. What you see on the slide was that under the data column here, that's the WCD data from Fermi. It's pretty brief, especially compared to the Argonne data. We tested several ways to get around this. But the matches were pretty low quality no matter what we did. We actually tried doing a Llama text augmentation process on the WCD data. So I was using a prompt that was to generate keywords and another text to supplement the existing WCD text and use that in the matching process. While that improved the number of matches by about 25%, there were still some quality concerns in some of the other augmented text lessons learned and WCDs. And so that's an area that requires a lot more confirmation and checking before it would go into a production level pipeline. But that brings me to some of our kind of next steps and where a future clinic group might want to take this work. The first is to continue to test the prompts for the lessons learned summary generation. So Helen built out a lot of ways to more seamlessly test this. And that's an area where there's more exploration still to do. We'd also want to continue working on the Fermi data a lot more, further tuning that methodology, adapting it to the data, and testing that text augmentation process to see if there's ways we can get higher quality summaries and higher quality matches. And finally, we'd want to test other large language models to really get the methodology and the use of LLMs on the summaries and the WCD text as high quality as possible.